video, we are going to decide whether pairs of expressions are equivalent. Remember, two expressions are equivalent if they always have the same value whenever we substitute the same number for the variable. Let's look at our first pair. P minus 2/5 P and 3/5 P. These are equivalent. Why? The expression P means 1 whole P. So P minus 2/5 P, this is the same thing as 1 times P minus 2/5 times P. And 1 minus 2/5 is 3/5, so that leaves 3/5 P. So P minus 2/5 P is equal to 3/5 P. Now, let's look at P minus 2/5 and 3/5 P. These are not equivalent. The first expression subtracts the number 2/5 from P. The second expression takes 3/5 of P. Those are different actions. For example, if P is equal to 10, then we have 10 minus 2/5, which is equal to 9 3/5. But in this expression, 3/5 times 10, which is P, gives us 6. They are not equal. Now, let's consider 7x minus x and 7. These are not equivalent. The expression 7x minus x means 7 copies of x minus 1 copy of x. That leaves 6 copies of x, so 6x. This is not always equal to 7. Now let's consider 7x minus 7 and x. These are not equivalent. They may be equal for a particular value of x, but they are not always equal. For example, if x is equal to 2, this would be 7 times 2 minus 7. 7 times 2 is 14, minus 7, which is 7. But over here, we just get x equal to 2. So these are not equivalent. Now let's consider 3 times x times y and 3 times x times 3 times y. These are not equivalent. The first expression is 3xy. The second is 3x times 3y, which is actually 9xy. The second expression has an extra factor of 3, so they are not always equal. Now, let's consider 3 times x plus 2 and 3x plus 6. These are equivalent. By the distributive property, 3 times x plus 2 is the same thing as 3 times x plus 3 times 2, which gives us 3x plus 6. So these two are equivalent. Now let's consider x plus y squared and x squared plus y squared. These are not equivalent. A common mistake is to square each term and forget the middle term. But x plus y squared is actually x plus y times x plus y. And when we multiply the first, we would get x squared. The outside is xy. The inside is xy. And our final two terms are y squared. So x plus y squared is actually x squared plus 2xy plus y squared. That is not the same as x squared plus y squared. Finally, let's consider x to the fourth y to the fourth and xy to the 8th. These are not equivalent. The expression x to the 4th, y to the 4th, this is 4 x's and 4 y's. But over here, this is xy, a total of 8 times. So there's 5, 6, 7, and 8. That's actually 8 x's and 8 y's, not 4 of each. So these are not equivalent. As you work with equivalent expressions, it's helpful to ask, are these expressions always equal? Can I use a property of arithmetic to show that they are equivalent? Or can I find one value that shows they are not equivalent? For future elementary teachers, this is especially important. Students often learn rules like distribute or combine like terms, but they may not always understand when those rules apply. Helping students test expressions, explain their reasoning, and use counterexamples can build much deeper understanding. Equivalent expressions must always have the same value. If two expressions only match sometimes, or if they perform different operations, they are not equivalent.